Welcome to Lab 36, which is titration. As simply put as I can possibly make it, titration just means you're going to figure out an unknown molarity of a base or the unknown molarity of an acid. You're going to do it with a known molarity of a base or an acid. So if I give you the molarity of an acid, but you don't know the molarity of the base, and you pour them together until you reach 7 pH, which is neutral, then you should be able to calculate your one unknown, which is your molarity of either your acid or your base. This is the formula that you need. And that N means for acids the number of hydrogens. So if it's hydrochloric acid, which you'll see in the lab today, there's only one H, so N equals 1. There's only one hydrogen in solution for each HCl particle. Another acid we'll be using in the lab today is H2SO4, which is sulfuric acid. And the N for H2SO4 is 2. The only base that we're using in the lab today is sodium hydroxide. The N for bases is equal to the number of hydroxides that sodium hydroxide or that the base has. Like calcium hydroxide, the N would be 2 because calcium hydroxide has 2 hydroxides. All right, this formula is going to be key to your success today. Let me show you how to do the titration. Please make a note that your graduated cylinder and your beaker are for the acids. You're only going to use these for your acids. And the urinalysis cup is going to be for your sodium hydroxide. You'll either be assigned hydrochloric acid or sulfuric acid today for your acid, or both if we have enough time. And your base is going to be sodium hydroxide. I'm giving you the molarity of your base, which is your clue that tells you your acid molarity will be unknown. So your goal today is to figure out your unknown molarity of your acid. That's the point of a titration. We have a known molarity of a base. We're going to find out an unknown molarity of an acid. Now you've got your urinalysis cup. The lab instructs you to get 50 milliliters of this and return to your table. At this point, make sure your hair is back, your goggles are on, and if you spill any of the base or get any on your hands, I have spray bottles of vinegar out, and you can spray your hands with vinegar and then go to the sink and wash the base off. It's pretty diluted, but if it's left on your hands for a really long time, it could cause a burn. I have my approximately 50 milliliters of sodium hydroxide, and I'm going to put that in my burette now. Let me show you how to do it. This thing is your burette, and there's a stopcock at the bottom of your burette, and I want you to pay really close attention to the fact that the numbers go backwards. So you're used to graduated cylinders increasing in number from the bottom to the top, and a burette is meant to help you measure how much you've poured out of it, not how much is in it at the beginning. So when you're measuring with your burette, always do final minus initial. So that means when you pour your sodium hydroxide in through this funnel at the top, you don't have to pour it up to the 0 mark. Any number up here towards the top should be enough, and write that number down. Now, since we have lines that go to the 10th of a milliliter, you'll have an uncertain digit that is at the hundredths of a milliliter. That's your initial volume. And then you'll drain the sodium hydroxide out of your burette during the lab. It'll be going down into your beaker at the bottom where your acid is until you neutralize the acid and hit equivalency. And then you'll have a final volume. So your final volume minus your initial volume will be your volume of base. That's how to use a burette, and that knowing how to do that is important on the American Chemical Society National High School final exam. Before you add anything to a burette, make sure that this valve is perpendicular to the burette. Close it. You may have been booby-trapped. If you've been booby-trapped, then when you load your burette, it'll drain out of the bottom. For this lab, we're adding base to the burette. There's your mnemonic device to remember what goes in the burette. It's your base. So here's my sodium hydroxide, and pour it into the funnel. Make sure your stopcock is closed. And as soon as you've poured your base into the funnel, take this cup over to the sink, spray it with vinegar, and then wash it out and dry it for the next period. You can see the measurement here at the bottom of the meniscus. There's a 5 on top and a 6 on the bottom. So you need to be really careful. This value here in between 5 and 6 is not 6 point something. It's 5 point something. You have to read burettes from the top toward the bottom. I read this value as 5.42, and I'll write that number down so that we can demonstrate using it later. 5.42 milliliters is my initial volume. Here's the information we have so far. You have put your 0.30 molar sodium hydroxide in your burette to some value that's close to the 0 mark at the top, but it doesn't have to hit it. Don't go above 0 because you can't measure that. And the acid I'm going to demonstrate in this video, since it is diprotic, is the sulfuric acid. And you're going to measure out 25 milliliters. Your graduated cylinder is what you're going to measure it in. Remember, the cup is for the base, and the graduated cylinder and beaker are for your acid. Here I am at my sulfuric acid station, and notice there's no molarity written for this. Let me reiterate. The purpose of a titration is to find the unknown molarity of an acid or a base using the known molarity of a base or an acid. So in this case, for this lab, we know the molarity of the base and we don't know the molarity of the acid. And you've been asked to retrieve 25 with this 25.0 milliliters of sulfuric acid. If you end up going over like I just did, then just open up the top and pour it back in. Here's my 25.0 milliliters of sulfuric acid. And here's my empty clean beaker. And there is a Teflon coated piece of iron down here at the bottom. It's called a flea, and that's for stirring. And so you'll pour your acid in. And as a safety tip, if you have any spilled acid, I have baking soda placed throughout the lab. And if you have any drops of anything on your lab bench and you think it looks like water and you're not sure, don't touch it. Just put some baking soda on it. If it fizzes and bubbles like that, then you know that it's an acid. Keep adding the baking soda until it stops fizzing and bubbling, and then wipe it up with some paper towel and put that in the garbage. Now the fun part, we actually get to do some titration. I've got my 0.3 molar sodium hydroxide, which is monobasic, here in the burette. I have an unknown molarity, 25.0 milliliters of diprotic sulfuric acid here in my beaker. And the only way that we're going to know today that we have passed through equivalency, which means that we have neutralized this acid with this base, is with a pH indicator. And the pH indicator that we're using today is phenolphthalein. Phenolphthalein. You don't need much of this stuff. In fact, what I'd like you to do is just use a drop. If 2 drops go in by accident, that's fine, but no more than 2. 1 drop will be plenty. This is my Flynn pH indicator chart. So we're using phenolphthalein today, and you can see that phenolphthalein will start to turn a color between the pH of 8.2 and 10.0. Now we put the pH indicator in with the acid. So when it starts with the acid, it's at a very low pH. As we add the base to it, it goes up, 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 slowly, slowly, and then very rapidly, when we hit equivalency, it just jumps with 1 single drop into this base region, and the pH indicator changes chemically and starts emitting a different spectrum of color. So we see it turn pink. That's when you stop. I'll show you how to do it. If you're using a stirrer and a hot plate, make sure your heat is always to 0. If you turn your heat up, you're going to boil your acid, and then your acid will be aerosolized. It will be a gas in the room, and that's super toxic and dangerous. So we'll be walking around making sure that your heat setting is always set to 0. The stirring part is kind of fun. Let me back up and show you how this works. That magnetic flea that's inside of your acid, if you start turning your stirring up, is going to start turning around. Now you don't have to worry about stirring your acid. There's a speed that is perfect, and that speed, I think, for today is between 6 and 7. You have 1 drop of indicator. Remember your indicator. If you don't have an indicator, this isn't going to work today. And you're going to add your base until you start to see flashes of pink color. And then you're going to slow down and add your base 1 drop at a time until it turns pink and the pink doesn't go away. Then you'll get your final volume of your base, and you'll be able to do all of your mathematics. I want you to have a source of pH indication that's more than just the phenolphthalein. So I've put out some pH strips. Go ahead and grab 1 pH strip out of this container. You also have a stir bar. So what I invite you to do is dip your stir bar into your acid and just dab a little bit on your pH paper. At the end of your lab bench, there's a color guide, and you can see that that acid has a very, very low pH, somewhere in between 0 and 1. We're going to use this pH paper one more time once we've passed into equivalency or through equivalency, and we hope to see the pH be a basic color, somewhere between 8 and 10, when the phenolphthalein turns completely pink. Initially, when I add the base to the acid, we see no color change. So you can add it rather quickly until you start seeing a significant color change to pink. I am starting to see some pink, and so I'm going to do a slowdown and stop occasionally, and as long as the color goes back to clear, as long as the pink goes away completely, you're doing a good job. Okay, now you can tell the pink is flashing with every drop, and we're getting really, really close. I can't tell you how important it is to take your time at this point, because every single drop adds enough. Ooh, that was a single drop to shoot the pH through equivalency. One single drop of base, and now my color isn't changing back. Once your color doesn't change back to clear, you're done titrating except for the mathematics. Wash your stir rod off, grab that piece of pH paper again, interesting. Let's go compare that to the color chart. Looks like a 5 or a 6. Now equivalency should be at 7 or higher. And this is really close to a 5 or a 6. So I have to make a decision to trust my pH paper or trust my pH indicator. And my pH indicator doesn't have a pH range written on it, but my Flynn chart does. So I'm going to choose to trust my phenolphthalein. And over time, what I'm noticing is that this is turning slightly more green. So at least what we can see is that there was a color change as we neutralized the acid with the base. Now you need to get your final volume measurement. So here I am at 23.22, and that's my final base volume. All right, this is as hard as titrations are going to get for you guys. We have our 25 milliliters of total acid volume, which is right here. You have an unknown molarity of your acid. That's what a titration is. We're trying to find that out. Your number of hydrogens on your acid is 2. So we have our multiplier. That comes from the fact it's H2SO4. When you're doing hydrochloric, which is just HCl, your N will be 1. Over on the other side, we've got a couple other knowns. We've got our final volume in the burette minus the initial volume. So there's our total volume of base, which plugs into the calculation there. And then here's our molarity of the base. All you guys are doing is solving for that molarity. When you're all done doing your titration, make sure your urinalysis cup has been sprayed with vinegar and washed and dried. The pH paper can go in the garbage. The stirring rod needs to be rinsed and just put back at your desk. If you dried it, that would be nice too. Just rinse that in your sink. All this is salt and water. And so we're going to pour it down the drain. Make sure that you rinse and dry your beaker and your flea so that it's perfectly clean for next period. Same with your graduated cylinder. Rinse it. You don't have to dry it. Just rinse it nicely with warm water in the sink and put it back at your station. All right. That's a titration. Good luck.